Welcome to this video on some strange magnetic numbers. A lot of maths in school involves finding a unique answer to a particular problem. You're supposed to follow some predetermined algorithm to get the correct value. This could be really simple addition, it could be something more complicated like adding two fractions, or even solving a simple linear equation. I want to do something a bit different today and introduce a different side of maths. So I'd like to share with you a different activity that involves investigating an equation that no matter what steps you do, you'll always get closer and closer to an answer, to a number, what I call a so-called magnetic number that pulls us closer with each step. And at the end, I'll be giving some exercises to help you understand why this happens. The techniques are first very simple, but you'll probably need a pen and paper to keep track of your working. Adding a whole number to a fraction involves giving them both a common denominator and adding their numerators. And the second technique is a little bit more subtle, but basically taking the reciprocal of a fraction is the same as flipping the numerator and denominator. That's it, we've got everything we need, let's begin. So the actual object we're going to investigate is this formula, which I've decided to call the magnetic formula. What it means is that when we take a number that we call m, and we add 1 to it, and then we take its reciprocal, it then spits out another number, which we're going to call m plus 1, like the next number in the sequence. So what's so special about this formula? Well, if we start by choosing a simple and easy starting number, we can find out what's so special. So let's go. So we add 1 to 1, and you get 2, you take the reciprocal of 2, and you get half. So our first number is 1, and our second number is a half. And then we're going to repeat this process again. So we would do a half plus 1. This would be 3 halves. Take the reciprocal of it, and you would get 2/3. If you want to get to grips with this idea, I really suggest you try it yourself by hand, and then compare your magnetic number sequence with mine. Okay, so we've done this. So what of it? Let's have a look at our list of magnetic numbers as fractions and try to spot a pattern. It's not very clear, is it? But what if we convert our fractions to decimals? Suddenly, a trend seems to emerge, which becomes even clearer when we graph it. These numbers are homing in on a value around 0.61 something, which is like a magnet that pulls in our other numbers. To me, at least at first, it's not clear why this process is attractive or why it would attract to this number, 0.61. But let's not worry about that. Maybe we can try with another starting number. Let's keep it simple and just start with 2. The second number would be 1/3, and then if we do the sequence again and again and again, and we look at its decimal and graph form, we'll see what happens. Once again, the numbers are being attracted to some sort of magnetic number around 0.61, 0.62. Maybe we still just got lucky and this is a coincidence. So let's try it for a third and final time with something quite different. Let's do a negative number, -3. After a few more steps, this one also seems to be getting attracted to this magnetic number. It seems no matter what we start with, that our numbers will get pulled closer and closer to this rather mysterious, attractive magnetic number. Wow, what's so special about this number? If you keep generating more magnetic numbers from almost any starting number and you continue forever, you'll actually get closer and closer to this value, the square root of 5 minus 1 divided by 2. I want to keep this video short but also intriguing, so I'm not going to explain why it's this number and why it's attractive, but I want the viewer coming across this for the first time to have an experience of what many mathematicians an experience similar to what many mathematicians have when they discover something, a mixture of surprise, curiosity, and frustration that they can't explain what they see. To guide your understanding, I suggest you attempt the following exercises. If you'd enjoyed this, please comment down below, like, and of course subscribe to keep informed of my latest efforts. So let's have a look at the exercises now. So exercise 1. Start with any starting number of your choice and calculate the first 10 terms. Then calculate the difference between each term. What do you notice about a pattern in the differences? Exercise 2. Look back at the first sequence that we did, where we started with 1, and look at the numerators of each fraction. What pattern do you notice? Exercise 3. Can you find a starting number that will lead this magnetic sequence away from the magnetic number, like 0.618, or can you find a number that just won't work? Exercise 4. Can you write a similar formula of your own to this magnetic formula and see if this also produces similar behavior, even if it doesn't home in on exactly the same number? You could maybe try something like this.